Hello everyone, I'm Rory, Product Manager for Mari at Foundry. In this video I'm going to talk about Mari's new features and future plans. Mari is known for how well it's able to facilitate high quality work and scale without limits. Our mission now is to facilitate high volume of work as well. This means improving Mari's artist workflows to match its high-end technical capabilities. Across VFX, TV, games, AR and VR, there is so much 3D content being created, and our goal is for Mari to be the one-stop 3D painting application for them all. To help us achieve this, we've been making some great additions to our team, including a dedicated schooled and trained UI UX designer who also has a history of working VFX using Mari, a proverbial recruitment unicorn if you will. This goal can be seen in the 4 series. Mari 4.0 was our first step towards a Mari that is easier to use and faster to learn. With the Qt upgrade requirements of the Visual Effects Reference Platform 2017, we took the opportunity to completely refresh the overcrowded UI, allowing you to completely focus on your paint subject. We introduced the Palettes toolbar to access all of Mari's power for a far more streamlined experience, allowing you to make quick adjustments to any of Mari's palettes and have them automatically fade away so you can get back to painting. Getting started in Mari had always required many manual steps, so with the refreshed new projects dialog, we now automatically create and connect the channels you wanted from the preset tab to an associated shader, allowing you to start painting right away without any additional shader setup. Being part of a larger look development and lighting pipeline means streamlining how you get your textures out of Mari is very important. So we introduced the Export Manager. From here you can manage multiple export targets for the same channel, make local or global overrides for size, bit depth and color space, and even automatically trigger post-process commands for executing command line tools like render engine format converters once the channels are exported to image files. We continued the improved workflows trend into Mari 4.1, where we endeavored to make color space management as simple as possible. Previously when picking colors in Mari 4.0, the color values would remain constant and the perceptual color would change when you switched to a channel in a different color space to the one you were in when you originally picked the color. When switching between channels with different color spaces in 4.1, Mari now calculates new color values to maintain a constant perceptual color to the one you originally chose. We introduced a new View Transform monitor for the scalar data, allowing you to view your roughness bump and normal maps perceptually linear. We also now illustrate what type of data is currently being shown with a new icon in the toolbar. We also expanded our OpenColor.io integration by introducing Mari-specific role names to configure the project settings color defaults. This makes it easier to coordinate color management in Mari for teams of artists using a common OSIO config file. We also improved selection groups. When a new object version is added, Mari now attempts to match the selection group's membership across the new version, providing the common meshes between the two versions have the same topology. This allows you to define your selection groups once and have them persist through all your subsequent model vertex position and UV updates. As a courtesy release to our customers still on the 3 series, we also included the color workflows in our final 3 series point release, Mari 3.4. All future feature work will only occur in the 4 series and beyond. Which brings us to where Mari is going. As I mentioned before, improved artist workflows are the key themes we're addressing within Mari, and we're working on many fronts, short term, medium term and long term. For those of you who saw the multi-channel painting prototype I demoed at Mari Live in February, we have since determined that for it to be a production-ready feature, its demands on graphics hardware is going to require a longer development cycle than initially thought, so we're putting it in the back burner as a longer-term feature. However, in the short term, we have a new feature that artists have been asking us for many years. I'd like to introduce you to Mari's new mirror projection system. Mari can now project your entire paint buffer from a symmetrical angle. This can be controlled by either a button on the left-hand side toolbar or from the new category in the painting palette. We've introduced the mirror plane mask too, that allows you to get a perfect mirror edge between each side of your model. This can either dynamically mask the far side of the mirror plane, or be locked to one side or the other, depending on what kind of surface you're working on. Finally, if your object is not centered to the world's origin, you can attach the mirror plane to an object or locator in order to get the best symmetrical plane you need. Mirror projection is currently out in beta and is releasing very soon. So that covers what Mari has coming in the short term. Now let me talk about our medium term plans. Our next area of focus is on our most highly demanded feature, a Mari material system. As Mari is known for letting you tell it how you work, we had the challenge to design a way that our material system could fit in with anybody's workflow. What we came up with is a system that is driven by the shader you connect all your channels to. Your active user shader will drive which shader streams your material will have outputs for, as well as allowing Mari to create layers and merge nodes that automatically span your project's channels. Mari's materials will be designed and created exclusively in the node graph, using a very similar workflow to our existing Gizmo system. However, once exported, materials can be applied to either Mari's layer system or node graph. We've also made the decision to roll out Mari's material system in phases, This will allow us to get materials to Mari quicker than if we waited until all our desired components were completed before releasing. So the user journey for our material system goes like this. As mentioned before, you start in the node graph where you build your material with procedural nodes. Next you'd export the material to disk, which shall package all images used in tiled and triplanar nodes so that they can be shared across teams. Material files can then be imported into the shelf. These shelf items will just be pointers to the material files and not load any of the data into your project. Once in your shelf, materials can then be dragged and dropped into the layer stack or node graph for usage in your project. At this point, Mari will import all your materials package images into your project. So this is what we are aiming to release as our phase 1 of Mari materials. Phase 2 would introduce the Geo Channels system. Objects and projects would now have slots for object-specific maps like ambient occlusion, curvature, and normal data. You could bake these from the Modo render palette or import baked map sequences exported from other applications. These Geo Channels can be integrated within your materials by using a new Geo Channel read node. With this Geo Channel read node workflow, we'd be able to introduce a procedural mask in Mari that could be driven by object curvature and ambient occlusion, giving you the ability to design far more complex and advanced layered materials. We also plan to refresh the shelf and make it far easier to organize, search, and filter your materials and brushes. Here is a prototype our designer made to illustrate how we envision working with materials will feel like in both the layers and node graph in a future version of Mari. Being able to apply materials from both the shelf and the layers palette menu matching the organizational structure of the shelf. Here is the current workflow for creating a multi-channel merge node. As is created, it automatically spans your project's channels based on the downstream user shader. Connecting this imported material to the merge node that shares the same shader model driven inputs and outputs will batch connect the remaining sibling streams to each other automatically. A single mask input drives the merge points across all the material's data streams. And Gizmo style promoted attributes can be manipulated in the node properties palette, and in the future within the layers palette as well. And here is a look at how the material will appear in the layer stack, complete with a new interface for interacting with the material's data streams. You can switch between sibling channels by clicking on the stream buttons without having to go to a different interface, as well as giving you full control over which material data streams contribute to your channels. For example, if you layered paint over bricks but wanted the bricks bump to propagate through to the paint layer. Now, as you may have realized, the Mari shader is a key driver for Mari's materials, and third-party render vendor shaders would streamline the process in the pipeline. In the past, Mari has included community-contributed shaders for various render vendors. These are mostly trial-and-error homebrewed shaders that don't necessarily provide the best user experience between Mari and the final render engine. Therefore, we are going to deprecate these shaders as unsupported. Existing projects will still work with them, but support for Mari shall end in the near future. At Foundry, we've reached out to various render vendors and requested that as the designers of the engine shaders, they design an approximation shader for Mari to provide our mutual customers with the best possible experience. So this means timelines are in the hands of our render vendor friends, so please let your render vendor know how much you want to see their shader in Mari. I'd like to close by talking about our future plans and the features we want to work on in the next few years. We want to fuel our upcoming material system by increasing proceduralism in Mari. That means more utility, procedurals, and adjustment nodes in the node graph and layer stack. We want to improve our session scripts feature to be a first-class supported feature with optimizations and enhancements to allow for a far more lightweight and version-controllable project entity. Then we want to create a background renderable mode for Mari that will use session scripts as a farm payload to increase your efficiency of getting your work down the pipeline. And of course we want to bring Katana and Mari closer together, so we plan to work on interrupt workflows that would benefit you to be more efficient when crafting your assets. All these new features and future plans are designed to make Mari the best possible 3D painting experience an artist can have, while also catering to the market trends of higher volume, at high quality, at reduced timelines. For Mari, the future is brighter than ever. Thank you for watching.